we stopped last time at coset and then Lagrange theorem. Every subgroup, the order of the subgroup divide the order of the group. The number of coset, we call it the index of H in G. Okay. And okay, 7.4. So I go to stabilizer and also orbit. Let me make this my WhatsApp is crazy. Okay. Notification turn off, mute. Okay, all right. Okay. So this is the total 7.4, right? The section. Okay. What is the name of the number of definition? 7.2. Stabilizer, okay, of a point. Actually, stabilizer is not only used in group theory. It's also used in many other areas when you apply group theory and this point. Okay, now stabilizer, it is set at a point. So this point will be the numbers that we choose. Since permutation is using Sn 1, 2, 3, so our point will be those. Okay. Let G be a group of permutation. Okay. And this permutation is on the set. One, two, three, until n. Okay, so that is why we use Sn, n from 1, 2, 3, and so on. Okay. Now, G sub I, so this I is from 1 to n. G sub I is all permutation phi in G. We call it that fixes I. Okay, the stabilizer is the set of permutation that fixes I. Phi of I is I. So definitely you see that the identity, if we call it G, sometimes we call it G is Sn. Okay, E is always in G since the identity send I to I. Okay, this identity we call it this, right? In Sn. Okay, so in this case, Gi is never empty. It is not empty because the identity is always inside. Because identity always fixes all numbers. 1 goes to 1, 2 goes to 2, 3 goes to 3. Okay. Okay, now the other one is called 7.3 is the orbit of a point. It's here. Orbit of a point. Again, let G be a group of permutation on the set. Then so instead of just now is all the set of permutation, this one just now is stabilizer, this one is orbit, this is the image of all permutation in G. of the set of images of A. If I is 1, I can be from 1 to n. So if I is 1, you will find all the images of 1, phi of 1. And it depends on what is your G. Okay? This G normally is not Sn. Normally we choose is a subgroup of Sn. If it is all of Sn, then the answer will be all of the set S, 1 to n. So we will find just a subgroup. Okay, look at the example. I have to give you the G, yeah? G 1, 1, 3, 2, 4, 6, 5, 7, 8. 1, 3, 2, 4, 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And then 7, 8. Okay, this is a subgroup of S8. If you need to show that this is a subgroup, if Hassan, are you there? I don't see your face. I cannot see whether you smile or just face of you cannot understand. Or it's okay, Wali, Amtinan, or not. Okay, you are given a G, a subset of S8. How do I know it's S8? Because maybe the highest number is S8, but I can also say it's S10, right? But this is given. And given this is a subgroup, right? How do you show it is a subgroup? How many elements? 1, 2, 3, 4, 5, 6. This is a subgroup of S8 of order 6. How do you know it's a subgroup? Kelly table is the easiest one. Okay, because you need to show that it's close, right? And so on. Okay, every row, every column has each element. So this is the this is the subgroup. Now we need to find the stabilizer. Okay, so again, GI is phi in G, phi I is I. So you can have I from 1 until 8, right? Okay. Now, G1, find permutation that fixes 1. That fixes 1. 1 goes to 1. This, right? Because I said identity has to be inside. Okay. Now you go to the next one. Does this fixes 1? And you see 1 goes to 3. So phi of 1 is not 1. Phi of 1 is 3, right? So you cannot choose this. This is not in here because phi of 1 is 3, right? This phi of 1 is 3, phi of 1 is 2, phi of 1 is 2, phi of 1 is 1. You don't see it, means 1 goes to 1. You don't see it, meaning you choose the one that you don't see the one except for 1. What is that? Choose the permutation that doesn't have 1 goes to something else, except for the identity, right? So this is your answer. Okay, just choose the one that faces that one. So you go to G2, again, if you see 2, means 2 goes to 1, didn't go to 2. So you don't choose this, there's a 2 here, there's a 2 here, there's a 2 here. So you use, okay. And G3, again, right? G3, there's a 3, there's a 3, there's a 3, there's a 3, there's this. G4, there's a 4, there's a 4, there's a 4, there's a 4, again this. Okay. Then G5, there's a 5, there's a 5, there's a 5, there's a 5. G6, there's a 6, 6, 6, 6. Okay. Now 7. And now you can see this inside, right? Okay. Now 7. There's a 7. There's no 7 here. Okay. So 7 goes to 7. So you can put here. And here, that not these two. So and this is also equal to G8, right? Because this no 8, there's 8. So the two are equal. So you can see that this 5, 6 are equal and 2 are equal. And you can see also that this stabilizer is also like an orbit, right? Not like an orbit. Like how many of these? 1, 2, 3, 4, 5, 6. And 1, 2, 3. Some of them, they are not inside, right? Yeah, like this one, because it has all numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. It has all numbers, so it moves everyone. Okay, so you don't see it inside. Okay, so this is the stabilizer. The other one is orbit. Let's go find orbit. Any question on this? This is clear, right? You need to see another subgroup to see another type of answers. Okay, now we go to orbit. Let me write out the definition of orbit again. I to the G is phi of I, phi in G. Okay, so you will need 1, 2, 3, 4, 5, 6, 7, 8. Phi of 1. So you have to go to each one and find the image of 1. Okay. Image of 1. So you see that I is always in here, right? I is always in here because identity will bring 1 to 1, I to I. Okay. So 1, 1 goes to 1, 1 goes to 3, 1 goes to 3, 1 goes to 2, 1 goes to 2, 1 goes to 1. Okay, so you take the images of 1 for each of the permutation. You can rewrite this as 1, 2, 3. Now you take the image of 2, 2, 1, 1, 3, 3, 1. 2. Image of 3, 3, Image of 4. The first one is itself because of the identity. Image of 4. 6, 6, 5, 5, 4. Okay. Image of 5, 5, 4, 4, 6, 6, 4. Image of 6, 6, 5, 5, 4, 4, 6. Image of 7, 7, 7 to 8. Decimal 7, 7 to 8, 7 to 8. Image of 8, 8, 8 to 8, 8 to 7. Okay. So you see the orbit is partition. We partition 1 to 8 into 3 subset, right? 1, 2, 3, 4, 5, 6, 7, 8. You remember coset, they are equal size, right? Coset, they are equal size. But for orbit, it's a partition, but not equal size. Okay, let's try number 34. Number 34. I give you 5 minutes. The question is to find some, but I want you to find all. Okay? A, find all stabilizers of I. In G for all I. B, find all orbits of I under G. This is under 6, right? Ambil gambar. This is a view. Masa dekat dalam nanti dia masuk ni kan, boleh pin. Hassan, you done? How's the weather, Hassan, in Afghanistan?
The weather is right now is cold.
How cold is your cold?
Cold. We already snow -0.
Oh,
Yeah.
zero is cold.
Yes. -0, -3, -4. Yeah, something. It's still not winter. The winter is not started, but after 1 month, maybe winter. But it's already cold.
Even in Malaysia, Vian is cold, right? It's not hot, not too hot, because it's raining. So I think it's quite cool right now. Okay, so okay, Hannah. So this one stabilizer.
It's solo the quarter bit.
Stabilizer is G sub I, right?
Yeah.
Okay, so for A, we have G1, G2, G3. So what is G1? Fixtures, right? The one that
one.
So where do I put the G of I is phi in G. Phi of I is I. Okay, so what fixes one? 1,
2, 4, 5,
there is
5,
one, there is 1, there is 1, there is 1, there is
2,
1, there is
4, 5, 6. 2, 4, 5, 6.
So you just collect all that has no 1. 2, 2, 2,
5,
2,
6, 1, 3.
6,
1,
1.
3.
Okay. 3, 3,
1,
3, 3,
2,
3,
4, 5, 6.
2, 4, 5, 6. Okay. We have 4, 5, 6. Still 1.
5,
4,
6, 4, 3.
4, 5, 6, 1,
1, 3.
3. 5, 5, 1, 2,
1, 2, 3, 4.
5,
1, 3, 2, 4.
2, 4. It's a
1,
5,
4, 2, 3.
4, 2, 3. Okay. And I think 6 is the same thing, right? With the 6. So these are equal. So the point is to choose the one that has no number, not none of the number inside. Because if there is a number in there, meaning it will move, it does not fix. Okay. Clear? Clear? Okay. Because I will erase. Clear? Where is your thumb? You have to get used to the new norm. If you like this, I cannot see from far. If you mute, I cannot hear. So just okay. Okay, now the orbit, right? So the orbit Okay. I sub G, right? I sub G. Waalaikumsalam. Oh, wow, by hand again.
Sorry.
Thank you. I sub G, okay? I sub G is phi of I, phi in G. Alright. So for B, we have to find 1, 2, 3, 4, 5, 6. Okay? And find the image. Find the image of 1. And 1, 2, 2, 3, 4. 3, 4, 1. Okay? Image of 2. 2. 2 goes to 2. 1, 3, 4. 1. 2, 2, 2, 2, 4. 3. You see if they are in here, they are all the same. Okay? 3. 3 goes to 3. 3 to 4. 3 to 4. 3 to 1. 3 to 2. I'm just checking, but actually, because it's a subgroup. Okay? If a subgroup is closed, then you get all this. 4. 4 goes to 3. 1, 2. 3, 4, 1, 2. Okay, 5. 6, 6, 6, 6. Also, 6, 5, 5, 5, 5. So you see this is a partition 1 to 6 into 2 subsets, one of order 4, one of order 2. They cannot intersect, right? They cannot be empty, they cannot intersect, so it is a partition. All right, so we are done with this chapter. We'll move on. You can read through. Okay. Normalizer and centralizer, I will mention again in the next chapter. Centralizer, you have seen it. Okay, centralizer, you have seen it. And normalizer is just the set in which the coset, they are the same. GH is HG. Okay, that is the normalizer. Okay,